Rivers are the cradle of civilization. They support various life forms and ecosystems. But they are prone to fluvial and pluvial floods, which can wreak havoc on many communities, infrastructure, and the environment. It is estimated that the economic cost due to these floods is around $8 billion worldwide. So, flood protection is vital for sustainable development of society. Governments worldwide spend millions of dollars on sophisticated flood prediction models. They rely on expensive sensors, gauges, and monitoring towers, which measure the water level, the velocity, and stream flow of the rivers. Because of its high cost, only a few percent of the world's rivers are equipped with them. And this is a problem. An excellent alternative indicator is riverbank width. In fact, there are various studies that show the ideal bank width for flood protection. But to use it, we need to monitor it along the entire course of the river. And here is another problem. There are multiple rivers spanning hundreds of kilometers in length. To simultaneously monitor all of them is either going to be very impractical or very costly. So the idea of my project is to use satellite-based images as a cost-effective and reliable source, computer vision for identifying the river edges and bank line, and an AI model to determine the ideal bank line, compare it with the real bank line, and classify the river into watch out, safe, or risk zones. For developing the solution, I'll divide the process into 3 steps. Step 1 for source selection, where we explored various layers of ArcGIS maps and Google Maps to find the image with well-defined bank lines, clear contrast, and minimum noise. We finally settled for a default layer of Google Maps as our source. In the next step, we used computer vision to find river edge and bank lines by first converting it into grayscale, and then applying Kenny edge detection algorithm, which includes Gaussian blur filter, Sobel filter, and edge hysteresis. In the last step, based on river width, our AI model creates ideal bank line and compares it with the existing bank line to classify river zones as risk or safe zones. Our model, when applied to RA river section, successfully identified and classified it as per its risk profile. As next steps, I would like to build an AI application around this model that links all images of the river section to create a single continuous view of the entire river and estimate time to disaster based on rate of change of river bank width.